All right, we're going to go ahead and get started here. Today we're going to be doing the exam review for 2110. There is actually a study guide. Um, there is actually a study guide. So if you go onto the uh, Colab page for our course, you will see labs and exam review. And under labs and exam review, let me go to the main page real quick. Here's exam 2 topics. Oops, sorry, you couldn't had the wrong screen share on. Let me move my head just that way you can. On the Colab page, lab and exam review takes you to this page. Exam 2 topics. There it is. No, it's not a debated twice. Um, I'm not. I'm not. I'm not that good. Um, I originally thought about using the Mario Paint version, but the problem is I don't want to play Rick Astley on stream because then this stream will get muted. And if the stream gets muted, then people can't watch the VOD. Uh, and I can't upload it to YouTube if it has Rick Astley. So that's why I can't. I'm not gonna tempt fate there and get the exam review stream muted. Wouldn't be fair to students watching later. Anyway, um, so the exam study guide is here. It's quite big. I'm going to go through it. So I just want to first, before we get into today, I just want to quickly set some ground rules um, that I'm going to work by. So the first rule, exam review ground rules. Pardon me. The first rule is I will not answer questions of the form will be on the exam, or can you go over blank? I don't have time to reteach a lecture today, so I'm not going to try. If you have specific questions, I'm happy to answer them. I'm happy to answer very, very specific ground rules. Um, we'll talk about that in a second, so we'll talk about the actual rules. But this is just because I can't answer these questions. From there, that's actually really kind of the only rule. Also, don't talk about Fight Club. That one's a rule as well. But I don't answer questions. Will blank be on the exam, or can you go over blank? I will answer very specific questions, but I won't answer just general overly broad questions because it just takes up too much time. Will blank not be on the exam? No, because you could put not in that blank and it would still work. So it would still fit into that blank. Anyway, so first and foremost, the exam format. The exam, you have allowed resources, textbook, notes, IDE, browser. Here's the simple reason those are allowed. We can't realistically stop everyone. So rather than make it a rule and then harm honest students, we're just going to let everyone use these resources. As such, I want to stipulate we wrote the exam in such a way that if you have to look up every single question, you will not finish. You won't have the time to finish. So there is value in actually knowing things. Um, but that said, these resources are allowed. You are not, however, permitted to collaborate in any way. And we will be using various cheat checkers on this exam. If we find that two students shared solutions, those two students will be given Fs in the course or non-credits. And that is a final decision that won't be appealable. So you're not permitted to collaborate with any human being on the exam. Um, no, an F in the class is much worse than an F in chat. I understand Fs in chat are bad, but Fs on course grades are worse. Um, the point is you're allowed to use any resource except other human beings. Um, because of the limitation. So this exam it again we're going any live interaction with human being. Um, simply put, me putting any restrictions on any specific web pages is something that we can't I'm not going to try to list every web page that I don't want because one, I'm sure there'll be a web page I don't count, and second, it will be by that I mean human interaction. Asking about increasing the time of the exam. Is that no? Increasing the time of the exam is not under consideration, and it will not be under consideration. The exam will be 1 hour, and it is your responsibility to make sure that you are taking the exam within a time period. Yes, the exam will be on Colab and on the Ford website. So I'll get to that in a second. But first, I want to specify we cannot answer questions during the exam. So I'm going to talk about how this exam is asynchronous and what that means in a bit. As such, again, we'll get there. Please be patient because literally the next slide answers like the last 5 questions I've received. We will not be answering questions via Piazza, email, Discord, anything during the exam day. So that is all of Friday. That also means we will not be if you plan to submit homework for late, we will not have office hours for that on Friday. Simply put, there will be no assistance available on Friday, and here's why. Because the exam is asynchronous, people can take it at different times. If we answer a clarifying question to one person, there's no way for us to distribute that, especially for people who have already taken the exam. And so as such, we won't be doing any corrections or anything like that. So do be aware. All right. So taking the exam will be on Colab. It will be available from 12 a.m. Friday morning to not 11:59 a.m. 11:59 p.m. Friday night. It will have a 24-hour period. However, once you open the exam, you will have 1 hour to complete it. This is specifically Eastern Daylight Time. So, for example, if you were Central Time, you would have until 11 p.m. Thursday night to 10:59 p.m. Friday night. So this is to make sure that no one can use time zone as an excuse for not being able to take the exam. You will have to complete the exam in 1 hour from the time you open the exam. And as soon as you open it, it logs the start time to us. You will have 1 hour to complete things. This includes the coding portion. So on exam 1, we were a bit lax with this because people were learning. I want to be really, really clear. On Colab, there will be a place where you enter the code that the Ford website gives you when you complete the coding question. If you do not have the correct code in that space, you will get a 0 on the coding portion. No matter what, no exceptions, internet out, power out, doesn't matter. If you do not have the correct code there, you will get a 0 on the coding portion of the exam. So, what I personally would recommend is make 100% correct. No part if you don't have the code there, I want to be clear what I mean by the code. There's a code. It'll look something like 595ACBC217. Give me 1 second here. I'm trying to answer one question, so it's hard for me to keep up. This code will appear when you finish the coding portion. And it won't be that number. It'll be a different number for every student. If you do not have the number for that in the Colab portion, your Ford portion will not be graded at all. You will get a 0 for the coding portion, no partial credit. However, if you have the correct code there, then yeah, certainly there will be partial credit on the coding question. But if you don't have that code there, we won't grade it. And the reason is this. This code is our way of making sure that you finish the coding portion within 1 hour. Because the website doesn't share a timer with Colab, we are limiting you to 1 hour for the entire exam. What if, like the previous exam, there's a problem getting to the second part? There were a couple students who had that issue. I will talk about ways to resolve it. Are the SDAC and normal exams the same? All exam sections are the same. Um, there will be, of course, for some situations with students, different time limits, but they are otherwise the same exam, correct? Will there be tricky questions? I don't know. Maybe. I don't know. That's possible. How many multiple choice questions are there? Several. More than 10. Less than a billion. Somewhere in there. I mean, maybe equals yes. I don't know. Um, I'm not going to answer specific questions like that. Yes. Yes, Bob Sherman. Also, that's not a very nice thing to say. Only SDAC, so there will be an SDAC exam. If you take, or even if you open, which you shouldn't be able to because it will be password protected. Um, if you open the SDAC exam and you're not an SDAC student, you will get a 0 on the exam. So no matter what else happens. I want to be really clear. I want to be really, really clear about this code we're talking about from the Ford website. I don't care what reason it is. If you do not put the code that the Ford website, the coding question website gives you into Colab, you will get a 0 on the coding question no matter what. No exceptions, no outs. There's no revisiting this. While this is incredibly strict, the reason it is this strict is because we are dealing with this being an online course. Would you suggest doing the coding portion first? I would not this is section 001, correct? Yes, we're section 001, the noon section. I would say doing the coding question first doesn't sound like too bad of an idea to me. I mean, I don't want to explicitly tell everyone take it first, but I would encourage it. This is the same type of code that we had to put for the last exam, right? Yes, exactly. It's exactly the same. So just be aware of that. Okay. Some general tips. Make sure your computer is plugged in and or your laptop is charged before the exam. I recommend plugging in. Make sure your internet connection is stable. This is a big one. Don't have multiple tabs open in Colab. This is not because we don't want you looking at Colab resources. It's because, if I'm honest, Colab is not the best website on the internet. And if you open up multiple tabs, sometimes Colab will lose track of your exam tab, which means it won't actually be auto-saving your input. Normally on Colab, every time you enter a choice or type something, it immediately saves that. I can't. I'm not going to answer questions of the nature you're asking. The best maybe kinda, and the reason I'm not asking them is answering them is because anything I would say would be inherently subjective. Like a question being tricky is subjective. A question being harder is subjective, and so I can't really answer that. Will the grading be stricter? So we will still be grading syntax errors. Um, should we expect the exam to be longer than the first one? I actually don't know. I don't remember. Um, I don't remember. The other problem is, and that may seem like a simple question. How many questions is it? 2 years ago, this class, the first exam had 30 questions. Last year, it had 30 questions. 2 years ago, the exam was considered easy. Last year, the exam was considered impossibly difficult and way too long, even though it had the same number of questions. Have the questions for this upcoming exam been changed? We didn't have an original one. That's the problem. We don't write the exam a month in advance. So we didn't have an exam, and then COVID-19 happened, and then we changed the exam. We actually didn't have the exam yet written yet. So that's why it's impossible for me to answer this question, and I just don't think this is a useful line of questioning. Rather, what I would focus on is not how hard the exam is going to be, but on understanding how you need to take it and understanding concepts about it. I this is why I don't find these questions useful, because what I don't want you to do is for you to take the locus of control outside of yourself. if people are already coming up with reasons that this exam was too hard or it was made arbitrarily difficult, you're taking the locus of control outside of yourself, and you're actually going to thus do probably less well on the exam, even if it were exactly as difficult as the exam a year ago when we were in class. So I don't want that to be something that people fall back on as an excuse. So with that, I'm not going to answer any questions about what type of questions, how hard it will be, because they're all subjective and impossible to answer. So that's the last I'll address that. All right. Make sure the computer is plugged in, your laptop is charged. If on the Ford website you get an error, this will happen to some of you. When you hit submit, it may say an error. All you need to do is hit the back button and then hit resubmit again. When you hit the back button, it will have cached, that is saved, everything you have typed, and that will still appear on the web page. You then hit submit again, it will submit that same code. So you don't need to retype the whole thing. If you see the error when you're submitting on the Ford website, simply hit back and hit submit again. That you at the absolute worst, I've seen that twice, and that's a coding question. All right. Computer, internet, power, etc. failures will not be a reason for a retake or an extension. We cannot provide extensions. We cannot provide retakes. Be in a situation where you are certain the internet's going to work for an hour, as certain as you can be, and be in a situation where you know your power is not going to go out, as sure as you can be. Obviously, bad things can happen, but I'm just telling you right now, we cannot, because of the nature of 600 students in the class, we cannot allow for retakes later after the fact. Can you write that? We did write that on the exam. I just want to make sure that it's on the honor form, so you will have the honor form available. But I just want to reemphasize again. Please, someone clip this. Someone clip me highlighting that and saying, if you are on the Ford website, if you get an error when you hit submit, simply hit the back button. All your stuff will still be there. It will take you back to the coding, but your code will still be there, and just hit submit again. Somebody please clip that. We also have it written on the exam. I just want to make sure it's not there. Clips are disabled? They shouldn't be. I will try to figure out what happened with that, because clips should not be disabled. If one of my TAs disabled, okay, they're not. All right, thank you. Okay. All right, possible coding question topics. I'm now going to get into the topics here. Possible coding question topics. Compare to or compare methods. Comparable or comparators, which are related to the first topic. Writing a constructor for a class in an inheritance relationship, like a child class. Writing a try-catch block and writing exceptions in the correct order. Yeah, 7 clips. Okay, it's working. As well as overriding a method either in inheritance or in an interface. These are the possible coding questions. We will not have a question for all of them. There will be some question or questions for some of these. Generally, it's going to be either 2 or 3 coding questions. That's what you can expect. You cannot post links. I can post links. I can post the link to the study guide right now. And this, I swear, I am not rickrolling you again. It's not a bit.ly link. I know that link looks terrible. That is actually a link to the study guide on Colab. I am not rickrolling again. By the way, I already showed you how to find that. And just to be clear, everything that I'm talking about in the slides is just, it's written here on this page. So it's not, yes, correct. Only for the coding question. So from there, the rest of the exam can contain any of the other topics. Please be nice in chat. I understand that some people are asking questions that you may think are simple, but to them they are not. We are still trying to figure out the review session situation, whether or not we can have one. Will the coding portion be equally weighted? No. To understand, the coding portion is typically 2 or 3 questions. We're not making that 50% of the exam. On the last exam, I think it was 20%, the coding portion. In last semester, we had it as low as 15% and as high as, I think, 25. But certainly it won't be worth 50%. It was 20% on the last exam. But I'm saying on previous exams, meaning last fall, we've had it as low as 15. So no, you would not expect it to be equally weighted. It's enough that you won't get an A on the exam if you don't do the coding portion. But yeah, can we go over a comparator or comparable? Not broadly. If you have a very, very specific question, I can answer it after I get through to that topic, because I'm going to now just broadly go over each topic. So software development, object-oriented design. There's no reason these two are on the same slides. It's just to reduce the number of slides I have. Software development lifecycle. You should be expected to know requirement, design, implementation and testing, deployment and maintenance. Should be expected to know how to differentiate requirements from constraints, how to differentiate functional and non-functional requirements. Again, for the sake of time, I can't answer general questions of can we go over blank. With object-oriented stuff, this had to relate to inheritance, so things like interfaces, as well as parent and child classes, runtime polymorphism, abstract classes, and the Java abstract class. The Java object class, excuse me. And this included things like the equals method, the default implementation of equals, the default implementation of hash code, as well as why the function hash code would be overwritten, as well as toString. Collections and event-driven development. So be familiar with the abstraction of collections. So for example, we talked about how you can do things like set s equals new tree set, and you can just as easily here say hash set. This is an example of abstraction. Both of those lines of code work. You should be familiar with the list, set, and map interface. So that is, for example, list and set, add and remove. The list get function, the fact that set does not have a get function. The map get and the map put functions. As well as be familiar with collections.sort and how that works. Real quick, can you please go over the difference between extending and implementing? You extend a parent class, you implement an interface. So if something is written as public abstract class something, then this is a class and you extend it. Public interface something else. That's an interface. And you implement it. You can't do correct because you cannot actually instantiate. One, you can't create a direct instance of set because it's an abstract class. But the second is think of it as set is a rectangle. Set is a quadrilateral, whereas hash set is, say, a rectangle, and tree set is a rhombus. You can't say any quadrilateral equals a rhombus, but you can say a quadrilateral. You can set a quadrilateral equal to a rhombus. You can't set a rhombus equal to any random quadrilateral. Advantages of set S equals tree set over tree set S. It's so that way you can swap the type of set, hash set or tree set, at runtime for whatever would be more efficient. All right. Event driven. So if you'll notice here, we have nothing about a coding question where you're going to build a GUI. So you're not going to do that. You're not going to need to know how to build a GUI from scratch. You should be familiar with what um, event driven is. And actually, yeah, that's a good point. Anonymous class versus inner class. Um, can you give an example of setting an interface variable to an object? Yeah. So let's say I have public class Steve implements something else. I know, I'm just so good with naming stuff today. At that point, I can just say something else s equals new Steve. That would be it. I mean, just because I can do that because this is implementing the something else interface. All right. The PowerPoint will be posted after the review, correct? Although keep in mind, there's literally nothing on this PowerPoint that isn't in the review page or the honor code page, but I will still post it. You can implement multiple interfaces in one class. That is correct. Yeah, thank you for that, Sammy Saxy. Okay. So you will be expected to know what is an action listener. How do you implement it? But that's the only part of the GUI you have. We're not going to throw panes at you or layouts at you or anything like that. But we may tell you, hey, implement some kind of action listener that manipulates something to be this or that. Anonymous class versus inner class, what I will direct you to, and just because, and I will circle back to this given time, but what I will direct you to for specific examples to that is on Colab, under resources, under Java code examples, under me. By the way, if you're going to send emails to me, I know this sounds pedantic, but like, my name is right there, and so many people spell my name wrong, and then I'll like politely correct them, and then they'll keep spelling it wrong. And the second time is what bothers me. Anyway, you'd be surprised how often it happens. So under event handling GUI, we have a bunch of different examples here. So for an example of button square root, and I'm just going to zoom in on this and enhance. This is an example of an inner class right here. What this does is this defines a class, and I'll just quickly copy this file. Hang on, I got to turn off screen share for a second, so that way you can see the different highlighting. I have to turn off screen share for a sec because I was working on something in Eclipse that is related to the homework, and I don't want to share that student's code with the entire class. That would not be appropriate. Okay. Um, so this would be an inner class right here. Let me scroll this. So this does all the work of the action listener. I define two variables. I then have the code that processes the input, generates the square root, returns it. I could easily change this into an anonymous class. All I would do, this is my method, right? So I would just say where I assign this new button listener, I'm going to delete what I have here, and I'm going to say class, or not class. It would be new action listener. And then in the parentheses here, this is where I would define my action listener class by copying this function and pasting it here. And hang on, it doesn't. Hang on one sec. Let me, because I actually do have the solution here on another page. Sorry, give me 1 second. I did something wrong. That's the inner class, and this is... Where'd my anonymous class go? Hang on. I thought I uploaded the anonymous class version. If I'll re-upload it, I'll go track it down and re-upload it. Although it's on my laptop, which is right over there. Um, Oh, sorry. I see what I did wrong. Sorry. Sorry about the delay there. I see what I did wrong. It's a new action listener that. There we go. I forgot the closed parenthesis there. Yeah, correct. That's all I did. So this would be an anonymous class, and all it is I'm defining still an action listener class, which means, and let me fix the indentation here. It doesn't seem to want to fix the indentation. Okay. No, I have the... Oh, I'm missing that. I'm missing that bracket. There we go. Okay. Sorry, I replaced the one and didn't replace the other. Anyway, I define a new action listener class exactly like I do up here, except I don't name it. So this is anonymous because I don't have a name for this class, and I just define it in line. So that's all I'm doing here. It's the same code. It's attaching to the button listener. And with an anonymous class, the advantage is we don't cloud up the namespace, because every object you create has to have or every variable you create has to have a name. Every class you create has to have a name. So we don't add something to the namespace. That is the names that we have to have in order to understand the program. The advantage of an inner class is if you want, it allows you to reuse the button listener, which you can't reuse an anonymous class unless you just copy and paste the code, but then you're actually really kind of... You're not being dry, which is don't repeat yourself. So, all right. Moving back on. So that's briefly anonymous class versus inner class. Are expect to know both? Yes. You're not going to write necessarily GUI code. Notice we didn't say you're going to write large scale GUI code. But yeah, you should be familiar both with implementing the interface in an anonymous way and in an inner class way. Okay. Exceptions. What are exceptions? What is a checked versus an unchecked exception? What is the exception hierarchy? So things like, what's the difference between IO and exception and a runtime exception? Be familiar with that. Be familiar with how checked and unchecked exceptions work. Which one Java forces you to handle at compile time. Abstract data types. So I talked about this a bit when we went over algorithms. The only two abstract data types that we really went over in detail were stack and queue. Now technically you can also say list, set, and map are also abstract data types. Whereas, so while I can say that, for example, list is an ADT, array list is not an ADT, and that's because A stands for abstract. A list is abstract. An array list is not. Is a hash table an ADT? So technically in Java, there's not an explicit thing that we've used called a hash table. So you could argue you could describe a hash table as an abstract data type. What I will say is that a hash set is a concrete data type. A set is an abstract data type. Stacks and queues are also ADTs. Abstract classes can have implemented methods, correct, but interfaces cannot. Now, technically, an ADT could be either an interface or an abstract class. It's not the same thing. It's really not... When we're talking about abstract data type, we're talking about something that isn't a Java term or even any specific type of programming language. An abstract data type is a more nebulous idea that exists at the high level of talking about code and computing. It's not a Java thing, whereas interface and abstract class, we talk about those in the concept of how they're implemented within a language, such as Java. Abstract data type is a more broad term. And be familiar with the array implementations of stack and queue, which are the implementations we went over in lecture. Last page, and then I will just open the floor for questions. Algorithms. Be familiar with what a definition of an algorithm is. What is a critical section of code? Asymptotic analysis. Be familiar with constant time, log time, log linear, quadratic, cubic, and how to look at code and determine the runtime complexity of it. Be familiar with linear and versus binary search. You should actually be reasonably able to implement those. Be familiar with the, sorry, I actually wrote this slide wrong, versus log linear merge. Now, we have not gone over how a merge sort works, but you should be familiar with how these work. I have already uploaded the code for those, which is to tell you that you're not going to write the code on the exam. But what is the definition of an algorithm? Well, let's show you where to find it. So once again, I keep deciding I'm going to show my desktop, which is not at all intended. So under resources, if you go to slides and in-class material, you go down to algorithms day 1, pick any one of these slide decks, and hey, look, here is the definition of an algorithm, and here's a couple slides that go over some of the qualifications, such as being precisely stated, deterministic, and terminating. Binary search code from Monday going to be uploaded. No. Wait, I thought it was already uploaded. I believe I uploaded it, but I will double check that. Again, though, it's to say that you should be able to implement it if we put different restrictions on how it's implemented. Are there any online practice or good tutorials? Not that I'm personally aware of. You did so in lab, so I could go back over that. I'm not particularly aware of. It should be uploaded under code examples. So again, all my code ends up in this folder, Java code examples, McBurney, and then scroll down, searching and sorting. Did I not? Okay, my searches aren't here apparently. I thought they were. I'll re-upload them. BSA 420, I have the same question. For an algorithm with a nested loop, is the critical section just the inner for loop? So it is the inner for loop, but keep in mind, so I want to do just a quick example. So at this point, let's define 3 functions. And let's say that I have a function called linear. Let me move my head here. Linear search, which is O of n, because of course it is. And then we have binary search, O of log n. Let's say I wrote a function like this called efficient search. And this takes in an array. And I define this algorithm as follows. And I'm going to use pseudocode for now. If actually, give me 1 second. Actually, let me do a different example. Let me do find last example. Or find I'm trying to come up with an example on the fly for this. Give me 1 second to do that. I know. This is going to take in two arrays, X and array Y. And I'm doing this in pseudocode. You can assume these are int arrays. So actually, let's make this easier. Let's make these list. List, integer, and list, integer. And what I want to do is instead, I want to call this union. And I write the following. For integer I in X. And let me create my output list. List integer out. If y dot contains I out dot add I. Return out. Let's say I had this code. My question to you, and let me move this up the screen a bit. My question to you is this code. What is the runtime complexity? Everyone take a guess. What is the runtime complexity? Okay, I see n. I see an n cubed in there, but I'm seeing a lot of n squareds. So, I can absolutely see how you look at this and think this is linear, but it is not. And here's why. This is not a constant time function. The contains method performs a linear search on the array. So this line of code alone is O of n. That is to say where n is the size of y. Let's assume these arrays are roughly the same size, that these are both size n. This is clearly n loops, but we are doing a linear operation inside of the loop. And so because of this one little function here, it's not as simple as one for loop, therefore linear. Because inside of the for loop, we are actually doing a contains function, which is O of n. Add is not n. Add is constant time. Technically, if you want to get into details, it's technically this, which means amortized constant time, and I'm not going to get into this. Add on an array list though is constant time. It can be n, but so here's it's okay. There's no simple way to describe this, so I'm just going to explain it in the only way I know how, and that is with drawing on the whiteboard. So technically, in a worst case, again, I'm just telling you what is correct. I'm not gonna try to shoehorn this into what the lab has said. So the idea is with an array list, we just add elements at the end until we run out of space. So 5, 3, 2, if I add 7, it adds 7. Now if I were to add 6, I need to double. So remember that grow if necessary function? It's exactly like this. 3, 2, 7, and then 6. And you may be thinking, well, that's linear. And that's absolutely correct. But the thing is, because we double the size of the array list, by doubling the size, by taking effectively 4 copy steps, because I copied 4 values over, I now get 4 inserts where I don't have to increase the size of the array. So effectively, for 4 steps early, I get 4 steps later for free, that means effectively 1. So if you do a large number of inserts, it averages out to taking constant time. However, any one particular insert in a worst case is O of n. But the thing is, because we're doubling the size of the array list, that gets exponentially more and more rare. And by exponentially more and more rare, I mean just that, exponentially more and more rare. In the context of the exam, again, it will depend on the wording of the question. Could you please give a code example of something that is log n and n log n complexity? Binary search is log n, merge sort is n log n. What was the complexity of the for loop in the example by itself? This is O of n, because this loops n times. Again, in this case, I'm assuming both x and y are both size n. So the overall loop is n, but this is arguably the critical section. Technically, it's anything that is inside of the loop. So technically, the critical section of this function is the code inside of contains, but you could say broadly, this is a critical section. It's inside of a loop. The answer will always be worst case unless otherwise stated. Correct. I want to be very, very clear about the array list thing I just said. We didn't teach it because it's amortized analysis and it requires a lot more mathematics. I just want you to see it, to see why I said add is on average constant time, but you should assume worst case O of n. So a critical section does not contain the actual loop. It depends. So for example, if I wrote this as a for loop, int I equals 0, I less than x dot length I plus plus. Technically, these two things, because they happen every time the loop is run, they are in the critical section. The code has 4 loops. Can it be complexity O of n? Sure. Depends on how the loops are. If the loops are in series, for int I, or let's just do for integer I in x, do something. And then after that, for integer I in y, do something. This is linear time because it's effectively 2 times n steps, which is O of n. If I nest the loops, if I put one loop inside of the other, now this is O of n squared. So this is O of n squared. Whereas that, and I'm trying to just fix the indents, this is O of n. Since the critical section can be argued, do exam questions take into account different people arguably correct answers? The questions will be written in such a case that it won't be ambiguous. For loops can be constant time if they iterate a fixed number of times. That is absolutely correct. Thank you, Jules. So for the last example, since contains was nested in the for loop, it was n squared. Correct, and that's because the contains function is O of n. I should also note this. The add function that takes in int index e value, that is to say, add at a particular index, this is always O of n on a array list. I'm not sure how it would be n cubed. The worst case for this example, I don't believe would be n cubed. I can't actually pull it back up, but that's because the contains and the add were in series. They were not nested within each other. No, because so this is O of n because they're in series. I do one loop, then I do the other. This is O of n squared because now they are nested within each other. So this is O of n squared. And so, for example, when I did contains and then add, remember, I used an if statement, not a for loop. This is still O of n, even though both contains and add would be O of n. So an add on an array list broadly is this, but we don't expect you to know this because we haven't taught it in class. So if you assume O of n for add, you won't be incorrect on an array list. But that said, why is the add function O of n? I've already gone over that. I'm not going to repeat it. Just I apologize. Go back and look at the replay. But I'm trying to deal with a torrent of questions right now. Yes, correct. If you add in the middle or literally anywhere but the end, this is always O of n. If you add specifically at the end, it is technically O of 1 plus. And the reason is because it's not linear time except when you have to grow the size of the array list. So if you're out of space, you have to call grow if necessary. It's exactly the same as what we did with a stack. If you do a very large number of adds, it will average out to taking constant time. But the worst case is still O of n because you have to copy the entire existing array list. Yeah. Yes, that is kstat. That loop is constant time. If you loop from 0 to 1000, that's considered constant time. Because if I double the size of whatever inputs that system, the 1000 doesn't change. Can we get an example of complexity log n or n log n? I've already answered that question. A log n function is binary search, and n log n function is a merge sort. So the overall complexity depends on the nested code and not the ones that are in series. I mean, so for example, let's say I had two things in series, such as contains and selection sort. In this case, this is O of n, and this is O of n squared. At that point, we would say this code is O of n squared because it's the worst case, because they're in series. Is there a general rule for complexity of while loops? They're generally going to be linear unless you do some type of divide and conquer strategy, like we did with the guess a number example, or like we do with a binary search, and then it's log n. What essentially is the critical section of an algorithm? Can you give an example? Sure. There, that's the critical section of the algorithm. Because that's inside of the for loop. Or in the case of a bubble sort, here's the critical section of a bubble sort. Selection sort. Here's the critical section of a selection sort. It's just the most nested section. Yes, if you have a series, you choose the worst case of the two, correct. Or three, because you can have more than two things in series. Yes, O of n squared plus n is the same as O of n squared, since as n gets larger and larger, n squared dwarfs n dramatically. If n were a very large value, the n term is too small to be noticeable. To explain essentially what the critical section is, it is the code in the algorithm that runs the most times. So this code inside the innermost for loop and selection sort, these lines of code are the one that we run the most. And so if we were trying to optimize our code, we would start by trying to optimize the critical section. That would pay the most dividends. Yes. If I've missed your question, you are welcome to repost it. I apologize, but chat has had significantly more messages than I can respond to, and I apologize for that. But it's just a limitation of me. Might it be possible for the in-class activity solution page to be updated? We're still debating that internally. We actually had a meeting Monday as to how many of the in-class activity solutions we will release. I will bring this up again with my colleagues today. But I can't really say anything more than that. Can you show different ways that super is used? It's too broad a question, but if you want to look at different ways that I used it, you can go under resources to Java code examples here. Under resources, Java code examples, McBurney. If you go to inheritance, you will see that I have an example alarm clock and clock. Alarm clock extends clock, And so clock is an object that can exist on its own. Clock is not abstract. Do we have it in class today? No, we do not. So for example, with clock, this is actually a class that can stand on its own, that works fine. Hang on, I have too many tabs open here. This class is instantiable, etc. This is not an abstract class, but we can still extend it. So extends clock, and this super keyword is used in the constructor to create the parent clock object. In addition to that, we call the parent's update method with super.update before we check the alarm. So that's one example. And we have similar examples in the triangle, right triangle, equilateral triangle examples. But so this is how, because I'm overriding the parent's update method in alarm clock, because in addition to updating the clock, it also checks if the alarm should go off. I do that here, and I still call the parent update method with super.update. All right, I'm running out of time here, and I actually do have something. Well, yes, correct. So this calls the because if you look, the parent class clock has a constructor that takes in a brand name. The alarm clock takes in a brand name, and so we just pass the brand name to the parent. All right. I do apologize. I'm gonna have to end here. I will try to get these slides uploaded. I'll get my searches uploaded as well. Apologies that I was really worried about lecture today because I knew I was going to get more questions than I could answer. So thank you all for being patient. It's difficult to get through all of it because I could have spent the entire hour answering questions and still not have gotten all of them. So thank you all for the patience, and best of luck on the exam Friday. There won't be a lecture Friday, but people have expressed interest in Jackbox party games, so maybe we do some kind of unwind event this weekend. If something like that happens, I'll post on Piazza, so look out for that. Anyway, that's just an idea, not something that's necessarily happening, but if there's interest, let me know. And otherwise, take care.